All right, here's some extra help on piecewise functions. This is for the Go formative for the 31st, I believe. Yes, August 31st. All right, so one of the ones that we were having trouble with was number 2. So number 2, it says g of 3 equals what? So when we have g of 3, what that's asking is when the x value equals 3. So my first step is going to be, let's look at my intervals. So these guys, okay? And what I want to do is I want to see where 3 fits in with these intervals. So let's try the first one. So say we have, so the first one is x is greater than -2. Well, I'm going to put in 3 for x. 3 is less than -2. I'm going to say less than, I'm sorry. 3 is not less than -2, so this does not work. So we're not going to use this one. All right, let's try the next one. Next one, we have -2 is less than or equal to x and is less than 5. All right, so now let's just put in 3 for x. So -2 is less than or equal to 3 is less than 5. That does work. So because it works, we can put it into this second equation. Now I'm just going to double check to make sure that the next interval does not work or does work. So the last one is x is greater than or equal to 5. So put in 3. Well, that does not work. So we're not going to use this one. So we're only going to use the second equation. So I'm going to go ahead and plug in 3 into our second equation. So our second equation was 2x squared plus x minus 3. Well, now I'm just going to put in 3 for x. So I have 2 times 3 squared plus 3 minus 3. So 3 squared is 9. So 2 times 9 plus 3 minus 3. 2 times 9 is 18. Plus 3 minus 3. Well, these plus 3s and minus 3s, they're going to cancel out. So this is just left with 18. So we can say that g of 3 equals 18. And that would be our answer. All right. So let's do another one. So for this next one, I'm going to do number 5 because that one's kind of tricky. So for number 5, we have g of 5 equals what? So, and this is saying x, when x equals 5, what is my function going to equal? So I'm going to do what I did before, and I'm going to check every single interval to see where 5 fits in. So let's do the first one. So we have x is less than -2. I'm going to put a 5 for x. 5 is less than -2. Well, I know that is not a true statement. 5 is way bigger than -2, so that does not work. So let's try my next one. So my next one is -2 is less than or equal to 5 is less than 5. Now I just went ahead and put 5 in for x. So this is x. Well, let's look at the statement. Okay, -2 is less than or equal to 5. That's a true statement, but it continues and it says 5 is less than 5. That does not work. So we cannot use our second equation. So let's try the last one. We have x is greater than or equal to 5. Well, plug in 5. We have 5 is less or greater than or equal to 5, and that is a true statement. So that means we're going to use our third piece. So just for clarification, this is number 1, this is number 2, number 3. 1, 2. All right. So because we're using 3, we have g of x equals -1. So g of 5 equals -1. So your answer is -1. Because it's just a -1, that means it's a straight line, and no matter what y value you have, that is going to be -1. All right? So say we did number 8. And number 8, we have f of x equals blank. And this is just moving forward. I'm just doing more of the ones that we couldn't understand. So f of 2 equals blank. And this time we're given the graph. So what we can do is f of 2 equals what? So that means when my x value is 2, what is my y? So I'm going to go to 2, and I'm going to look at where we cross on our function. Okay, so I see that we cross at 2 places, but, this is a big but, there's an open circle right there. And an open circle means that it cannot exactly equal. It can get really close to that number, but it's never going to exactly equal. But then I notice there's another point. There's another point and it's closed. That closed circle means that it can equal. So at 2, f of 2, it equals, my bad, at f of 2, we equal 3 on the y. So 3 would be our answer. All right. So let's do 9. So number 9, we had f of 1 equals blank. And that's when x equals 1. And this is another tricky one. So we go right here and we look at f of 1. Well, I notice that we cross at 2 places, but the circles on those places is very important. So we have an open circle here and a closed circle here. So what that tells me is when there's that open circle, it's not going to equal. There's no solution for an equal to 1 on that part. But we have a closed circle right here. We have that closed circle, so that means when my x is 1, it will equal 1 on that point. But it will never equal 3 because of that open. So you could say that open circles are not equal. But if you have a closed circle, it is equal. Okay, I hope that makes a little bit more sense. I'll do one more. I don't want this to be too long, but it already is. All right, so for this one, we have number 11. Find values of x when f of x equals 4. So you can also think of this as when your y value equals 4. So when y equals 4. And we can put a line on our graph. So I'm going to go to y equals 4 and put a line right there. And I notice it hits right here and it hits right here as well. So it hits at x equals -2 and it hits at +4 as well. All right. You might be thinking, Miss Smith, but my function ends right there. Well, no. It goes to positive infinity forever. That arrow means it keeps going. It never stops. All right. The last one I'm going to do is number 13. And this one you had to write the equation. So for this one, we're going to do this first piece right here. And then I'll let you do the other two because they're a little easier. So for this one, I noticed that it's a parabola. And I think back to my parent functions. So I got to think about if I have a parabola, that means we have a quadratic equation. And then a quadratic equation, that's going to be y equals x squared. So for this first piece, my equation is going to be f of x equals x squared. Now that's the first part, but now we got to do the interval. So the interval is where it has x values that exist. So one trick that you can do is we can draw a line on a very straight line. And then I'm just gonna make it a little bigger. So I'm gonna take this line and I'm gonna drag it across my graph. Now it's not very smooth, but I'm gonna drag it, and wherever it has the function touching, well, that's gonna go. So it starts at it starts at negative infinity, and it goes all the way up until 1. Because it has that arrow, that means it's going to keep going left forever. So we have negative infinity to 1. And then since we have that closed circle, we have a bracket. All right? I hope this helps. Let me know if you have any more questions.